safe from attacks? As new technology emerges to combat security and safety issues, not every connected device nor company is completely safe. Sometimes, hacks to your system are inevitable. In this week's Embedded Insiders, Brandon and Rich are joined by Curt Schwaderer, the Technology Editor at Embedded Computing Design and Vice President of Engineering at Yaana Technologies, to talk about threat intelligence, more specifically, the motives behind today's hackers and how hacking has evolved throughout the years. And by Vincent Scott, the founder of the Defense Cybersecurity Group and Chief Security Officer at STI-TEC, to talk about government and commercial regulations surrounding cybersecurity. Time to market is an important aspect for nearly all technology companies. There is an urgency with releasing products and moving to the forefront of technology. But every product must await approval before it can be released to market. Scott offers his insights from the Department of Defense and what is being done to advance technology while also ensuring products are safe and ready for use. Finally, Brandon fills in for Perry in this week's Tech Market Madness to talk about how Sharon Brizanov, the principal vulnerability researcher at Clarity, and his team perform threat modeling and attack vector analysis. They recently found vulnerabilities in Weeboo Systems' CodeMeter, a widely used licensing protection solution in the industrial control system space. The White Hat researchers exploited these vulnerabilities, which resulted from poor implementation of an encryption solution, not encryption itself, as a means of potentially accessing ICS systems from major global automation suppliers. What it took to accomplish this will surprise you.
We've always been taught that you need to make your system as secure as possible so you don't get hacked. And it's obvious. It should be pretty simple. Make it secure so nobody can hack it. What I'm learning now is that people are pivoting to a different idea, a different philosophy, a different opinion. And the opinion is that I'm going to get hacked. There's no way around it. No matter how secure I think my system is, I'm going to get hacked. So now it's more important to accept that and make sure when that inevitable happens, what gets stolen from me is either nothing or something that's not valuable to my company. So I'll start with you, Brandon, because I know you always have an opinion on everything. Is my opinion correct, or should we still be saying, no, you're not going to get in because I'm using the latest and greatest?
Well, I think that it needs to be a two-pronged approach, right? You still need, you can't just accept, well, I'm going to get hacked, so I'm going to not put as much effort into securing the system up at the forefront of the design. However, one of the difficult things about accepting that you're going to get hacked is, while it's true and, to some extent that every company that is connected, which is essentially every company in the world right now, whether they're creating technology or not, is susceptible to data breaches, to IP theft, etc. The problem is when you get hacked, what are they going to, what's the goal of the hacker? What are they going to take? Like I just said, it could be IP theft. It could be looking for sensitive data. It could be looking for access to your systems to remotely control and monitor what's going on. It could be ransomware. So depending on the use case, depending on the systems, depending on the scenario, how do you even guard against, I know I'm going to get hacked, so I'm going to try to mitigate that, because it could be, pretty much anything that's happening.
Okay, Kurt, what do you say about it?
Yeah, I think the notion of worrying about preventing getting hacked and what happens when you are hacked is actually from the outside might seem like the current trend, but it might be a little bit outdated, Rich. So maybe we'll try to up to speed you here. While those are important, but they focus on verbs and actions. What I'm finding in the industry is doing now is they're worried more about something called threat intelligence. Mm-hmm. So this kind of flips security on its head by not focusing on the act itself, but trying to figure out, okay, what are the motivations? What kinds of goals do these bad actors have? Then analyzing your IT and OT systems to determine how they can succeed on those goals and motivations. So, to me, I think it's evolved. The chocolate coated shell of preventing things to get hacked is kind of the detail behind really trying to focus on how you create comprehensive security.
The world that we're living in today has somewhat turned this on its ear because of the remote workforce. With a large percentage of the employees working from home, how do we ensure that now those systems are secure? Because you don't even know what's going on. I mean, is your kid's Xbox plugged into the same network as, that you're using to access your company's internet? Or, Xbox probably a bad example, but there's so many devices out there that can simply be plugged in. And what I always go back to is, who would want to hack my toaster? Well, if you hack my toaster, now you're into my company, not just my own stuff. So Where does that take us?
Yeah, and that becomes the complicated question. And I think that's where the idea of focusing on threat intelligence can help, because, like the solution you were mentioning, where you try to build a shell, and then but that assumption is that everything is centralized. So if you have remote hubs that are connecting to strategic IT and OT systems, your sensitive data, you can pretty easily, VPN encrypt, do the kind of standard things to minimize being able to crack the shell. But like you mentioned, who knows what these home workforce environments look like? They have Wi-Fi's. Are they protected well enough or not? What's connected to them? Are techniques to hack into people's Alexas going to result in getting access to corporate information at the home? It's a complicated problem to solve, but I think it can, taking a threat intelligence approach where you're worried about the strategic threat intelligence, right? Like non-technical views of what the risks are and what its impact are to your business. And then you consider, okay, how does my remote workforce, how does that figure in? Where's the attack vector? And then oftentimes the employees, the important thing is, what do they have access to? Can I restrict that in some way? Can I put mechanisms in place to secure data, at remote workplaces at home?
When you're talking about threat intelligence, what does that mean exactly?
Right, it's just kind of a new perspective where let's focus on you kind of think about, okay, here's my company. How could somebody bring it down? What would be a big problem security-wise? For medical companies, it's quite often, what if somebody gets access to my medical records? That's a huge problem in the United States and abroad. Those kinds of things. So once you identify the non-technical threats, then you start worrying about what are the tactical ways that bad actors could penetrate the system to do that. And then that kind of gradually leads you into, okay, let's worry about the nuts and bolts, hacking methods that could achieve those goals, and how we can secure our environment, both, at our central locations and at the remote workforce households, to mitigate it.
Yeah, so essentially, threat modeling is a term used here. So the next steps after you've sort of done an analysis, like you said, Kurt. This is our organization. These are the assets that we have that are potentially of interest to some bad actor. Now let's model, how they could potentially get in. And I think that these two conversations we're having at the same time are really pertinent because, your threat modeling world just exploded by having all of these various individuals working, remotely from home. I know that the DOD and defense prime contractors here in the States have implemented some sort of abilities to do this in the past, the laptops that have specific security clearances on them and, additional security mechanisms in the hardware, et cetera. But, most enterprises, this is a whole brand new ballgame, and it's going to be interesting to look at what is the investment right? What's the investment that you're going to have to make to enable your workforce, depending on how big it is, to be able to operate securely? And then like with everything, like with security in the past, you're going to have to do a cost benefit analysis. Are we able to be more efficient or get the talent that we want, versus spending, I don't know, what is it, let's just throw a number out there, $1,500, an employee, to keep our stuff relatively safe. Is that worth it? And, that's why there are, actuaries and people who make all, way more money than me out there.
Where'd you come up with that number? Is that a real number?
Well, no. I'm just saying, what does a secure laptop cost? Obviously there's going to be more expense, but.
Right. And one simple thing, quote unquote, lots of people in the United States, if you've got a cable modem, you've got two different networks. You've got a 5G network and you have the standalone network. So oftentimes what happens is some new security measures involve companies, and I've seen this with ours and others. They take over one of your Wi-Fi networks, right? So you no longer know what the password is to that network, and then they allow you to connect to and use only that part of the network. So basically the family, and if somebody's using social media, which is another part of threat intelligence, is how can social media play into this at the home too? They're isolated. So that's kind of one way you can kind of separate home life from work life.
Well, yeah, and I mean, let's just take this for an example, like really quick case study. So to your point, Kurt, there's a 5G network and there's a 2.4 gigahertz network, and I have an extender because my house, where I plug in my main modem is too far away from my office. So now I'm dealing with this is an exponentially growing problem now. Yeah. So I know at Yaana and in your past, you've done a lot around lawful intercept and DPI. Is it realistic to be talking about using some of those technologies to monitor network traffic and see what's going on in these instances?
Well, in theory, but like you said, the costs are just not comparable to the risk. It's far more cost effective for companies to just say, okay, well, there's a point at which it's just too risky, too expensive for us. Like, you're never going to see a medical company allow employees to remotely download, HIPAA things from databases. That's just never going to happen. But, to an extent, a lot of what the threat intelligence technologies are evolving do involve some amount of DPI, where they're analyzing social media, what network elements are being accessed and those kinds of things. So I think at a basic level, in the next couple of years, you may very well see that, because that probably is cost effective.
Now, you mentioned 5G. I was going to bring that up. It seems like the problems often arise with a new technology that things just happen that people haven't thought of. And 5G might not be a good example because it's so well thought out. But whenever somebody plugs in something new, a hacker says, I bet they didn't think about security in this. And that's where we often run into problems. Is 5G vetted enough that we're not going to have this issue?
No.
Wrong answer.
Yeah, I wish, but we're especially in all around the world, but even in the United States, you've got this rush to being first. So it's like, let's do the make it work phase. We know some of the security is important, and we're doing a better job there, but they're not trying to comprehensively analyze the risk. And that's another aspect of threat intelligence. It's almost kind of like the agile approach to security, where you analyze past attacks, you try to apply them to the new situation. You don't attempt to freeze your progress by trying to overanalyze a situation where you probably could never get all the answers anyway. And then you evaluate, postmortem, address, and move on.
What we're referring to is a pretty vanilla 5G. Once you start to use it in the car and in other places, it's going to go off in different directions, and that's where some of these threats will be.
Yeah, and actually, that's what I was going to touch on. Is approaching the security problem, I don't think can be like technology specific. This is one of the reasons that making standards for this is such a pain, right? Like the technology moves so quickly that by the time you ratify a standard, anybody who's ever worked on a standard, we've worked pretty closely with some standards organizations just on the periphery in the past. That just getting everybody in the same room to sit down takes 6 months. So by the time you actually get something workable that's technically robust, the technology is light years down the road. So I think as another alternative, a different way of looking at it from the technology perspective is going into some of those, IEC, ISO models that are already out there that are more frameworks for how you would go about looking at your systems or handling information and data. Like the one I'm thinking of right now is ISO 27001. Like what Curt was talking about with threat modeling. It outlines this methodology for plan out your system, like design it in a certain way, check for all of these different potential vulnerabilities or, potential different use cases of what a hacker would potentially be going after. Or let's put hackers aside for a minute, even just, your own malware that's out there, buggy code, all of those things, and then have obviously a response plan in place. So that's plan, do, check, act stuff.
Exactly. And to be fair to 5G, I want to back up for a minute. Systems today are putting tools in place, right? There's inherent encryption security in 5G. There's inherent isolation between virtualized objects to prevent some of the some of these problems. But again, these are tools that are in the toolbox that are in place. You need to build systems on top of them that take advantage of them appropriately.
When you talk about the toolbox, we've been saying for a couple of years, what's the right starting point? You got to make sure that, when you're developing your code, you're checking the boxes and that your MCU is secure. Has that changed, or is the path to a secure system the same today as it was a year ago, 2 years ago, and will it be the same a year from now?
No, I think the bottom up, what you're talking about, where that's an important part of the initial, development and deployment cycle. You have to worry about, security from the bottom up, and I think that will always be a part of this because, the top, what was missing before and what's probably not evolved as well as we'd like now is the top down. So I think that's always going to be a part of the security. It's an important part of the security environment. But it's only one piece.
Top down. What do you mean by that?
Top down means that again, these threat intelligence models where you understand what the main goal is, because motivations for hacking into a financial institution are very different than motivations for hacking into a medical. So the use cases are different. They may use these nuts and bolts tools differently to achieve the right security outcome. You can't just create I've got a problem and I'll solve it this way. Otherwise, we'd have one universal security company who would just implement something once and it would work everywhere.
Isn't that what Amazon's trying to be? Just kidding.
That's a whole other conversation in terms of information gathering and.
But where you really run into problems is when you attempt to retrofit. It's one thing to start your design secure, but I got this thing out there and I got to make it secure. And the IoT is well known for having so many vulnerability points. People trying to do retrofits.
Right. Yeah, and the legacy issue. The legacy is an issue.
Yeah, and actually, this loops back to a topic that we touched on in our last episode. And Curt, I'd like to get your thoughts on it. It has to do with shift left and agile DevOps, continuous integration, continuous delivery. One of the things that IoT enabled was more of that type of thinking, because it's like, we'll release. And it's okay because we're connected, so we can just send an update and fix bugs or add features, and that's great in theory. Now, in practice, it depends, like everything. It depends. What's the system you're dealing with, right? How fast are you releasing this code, and do you have quality checks in here? And I'm sure that at Yaana, you and your customers deal with these sorts of scenarios all the time where they're like, we've got to get to market right now. What do you see as the trade-off? Because what we were trying to resolve on that last episode was, necessarily by putting in the things that we all know and love and embedded, static analysis, doing all of this QA, extensive, dynamic analysis and unit testing, all of those things. Yeah, you can do them in an agile environment, but doesn't it kind of defeat the purpose?
Let's do a finger wagging moment to the CEOs and executives out there for a moment, because you touched on an important part. But what happens is you have a set of requirements, everybody agrees to them. You do the threat analysis, you implement the security for the IoT. Well, all of a sudden, some marketing guy figures out they can make $2 million if they just add this feature.
Right.
What they understand is if you're not doing a comprehensive security analysis on what the impact is, you may have just created a hole that's going to cost you far more than the value of what's going on. And the rush to market when there's revenue involved can derail security so fast. I mean, over and over.
Yeah, that's the one we were talking about last week, where the marketing guy says, if you can get this done 3 weeks earlier, our window is wider. And they say, just put that in later, we'll do an over-the-air update. And I think Brandon was actually accusing you of doing that, Kurt, pushing those products out earlier and then doing the updates.
Hey, now, come on. Let's leave my job out. I know, I understand it. It's natural, but it's, again, something that needs to be tempered. And, instead of putting in a last-minute feature that increases the revenue you can get, my message is let's make sure you're analyzing what the impact to your security plan is and if it opens new threat intelligence.
Now, the insiders are joined by Vincent Scott, the founder of the Defense Cybersecurity Group and Chief Security Officer at STI-TEC.
Before we get into the topic at hand, I'm looking at your bio, and you are a cryptologist for the Navy. What exactly does that mean? What does a cryptologist do for the Navy?
Well, I think that the Navy cryptologic community is one of the most interesting ones out there. The U.S. Navy, going all the way back to the Second World War, has developed and maintained a separate officer and enlisted career fields that focus on reading other people's mail and protecting ours, right? So in the Second World War, everybody's really familiar with the breaking of the German and Japanese naval and military codes. We continue that work up through today, and primarily do that under the umbrella of the National Security Agency now.
Yeah, as it turns out, actually, my grandfather was a cryptologist in World War II, stationed up in Greenland, trying to intercept communications to German U-boats sitting off the eastern seaboard. So
right, HFDF, right?
Yeah.
And we used to have HFDF sites across the globe. Those are all gone now, as the world has moved on. But that was a lot of that going on there. Have you ever read Huff Duff?
No, I have not.
So that's a book, Naval Institute Press, HFDF. The nickname of it was Huffed Up, and there's a whole story of how that helped win the Battle of the Atlantic. It's a decent book. Huff Duff, HUFFDUFF, and it's about the HFDF and the use of intelligence and how we did high frequency direction finding in order to cross. Each one of those lines of bearing gives you a fix on a German U-boat potentially, and use that to target German U-boats.
That's great. Well, moving right along, Vince,
on to topic.
Right. Historically, obviously, the DOD and the three-letter agencies we're always at the bleeding edge of technology, but now we're entering this world where the commercial sector, the private sector, is way out in front. However, we're now in a middle ground where we've got to have standards and regulation around cybersecurity. We've seen all of these different hacks, and that the government has implemented things like NIST's cybersecurity standards to help protect critical infrastructure. So those two things don't really go hand in hand. On the one hand, you want to be out in front as far as you can on the most advanced technology, and on the other hand, you've got standards which are traditionally really slow. So out of the DOD's perspective, what are they doing in the cybersecurity standards realm, and how does that play with the need to have bigger, better, best technology?
Oh, it's clearly a conflict, right? There's tension between those two things, and one of the real problems, and I actually talk about this quite a bit with members of the Department of Defense, that the speed of regulation advancement does not match the speed of technology advancement, and that is a problem that we have in the standards today, and that's going to continue to be a problem, and it's just one of the things that we're going to have to deal with as we look at effective mechanisms for driving a better level of play across the Department of Defense and the defense industrial base that supports DoD, and the need for innovation, the need for small companies, the need to drive new cool technology and enable companies and entrepreneurs and inventors to be able to do that. But at the same time, we want them to be able to do that in a secure fashion. And I think there's definitely tension between those two poles. The DoD has an approach to that. They have chosen to develop a new standard called the Cybersecurity Maturity Model Certification, and tell industry that over the next 5 years, we expect all of you to obtain and maintain some level of compliance. And it's a 5-level system, right? 1 the lowest, 5 the highest. You're going to have to be at least a level 1 if you want to sell through to DoD.
So for the cybersecurity maturity model certification standard, is that, would you say, a gold standard in the context of cybersecurity standards today?
No, unfortunately not.
Okay.
It is based on NIST 800-171, which is the previous standard that the DoD and the federal government were using to tell industry what cybersecurity controls they wanted them to have. That is the core of the CMMC standard. The CMMC standard adds above and beyond that, depending on your level. And that standard honestly has challenges. There's a number of things about it that I really don't like. There's a number of things about it that are stuck in the past. It very much was written in a time when we looked at a lot of on-prem architectures for companies, and no new company is starting on-prem. You're not putting servers up in your office closet anymore. That's not the way this works. We're cloud. Right? Haven't you heard of Amazon?
Right.
Right. So companies today are not looking to build on-prem infrastructure, and a lot of the regulations and parts of the standard are really based on a presumption of on-prem infrastructure that really is not a valid presumption for new companies coming along, in particular. Older companies that have been around, if you've been around for 15, 18 years, you probably have some on-prem infrastructure, and maybe you're adopting some cloud, maybe you're hybrid on-prem cloud now. But those companies that are probably more mature and larger as well, they have on-prem infrastructure still, et cetera. But even they are starting to move very rapidly to the cloud. If you want any new application for your business, that's going to be a cloud-enabled application, and it's going to be priced in a way to discourage you from having software on-prem, racking up a server that does this, and they want you to use their cloud instance, and they are pricing it in a fashion to really encourage you to go towards their cloud instance.
Sorry, go ahead, Rich.
Speaking of making assumptions, we started this interview with the assumption that the private sector is ahead of the military in terms of security. Is that an accurate assumption?
If I said they both are terrible, would that make me a bad person?
No, it probably make you somebody who tells the truth. But
yeah, we really suck all around. I talk about college club sport defenses playing against the Tom Brady, Bill Belichick offense with a tarp over the scoreboard. It's awful out there. It's ugly in the trenches. And so when I talked about CMMC earlier, I talked about raising the level of play. So given my view that really the vast majority of companies are really terrible at this, have very small programs, aren't looking at it at all. It's just not something they do or do well. And even those companies that have programs often are sub-optimized, not well implemented, et cetera, have a lot of holes and problems with them. I hope that CMMC is going to make this a topic of conversation across every defense industrial based company. It's going to make them look at what they're doing. It's going to make them think about it. And we're going to see some advancement of the level of play holistically across DoD contractors. I think it's going to have that effect. I think it's already starting to have that effect and generate the conversation. Now, the painful part of it is, well, the standard doesn't deal with cloud well, or, you know, this control doesn't make sense now because I'm not on-prem, or I don't do things that way anymore, right? We had a conversation the other day about split tunneling, right? No split tunneling is part of the standard, but there are some cases now where I want to do secure split tunneling, and that makes a lot of sense, but done securely, done right. So those are the types of things where the standard doesn't advance fast enough. Now, the other thing that this is bringing is accountability. There are going to be independent third-party assessments of your level of compliance. So any company that sells through to the DOD, so not necessarily a prime contractor, you may not consider yourself to be a DOD contractor. But if you, in the words of Katie Arrington, the DOD CISO, mow the lawn at a DOD facility, you're going to have to be at least level 1. So I think all the companies in the space that you guys talk to, right, who are cutting edge technology, who are developing these things, they need to think about where their components are ending up and whether or not that's going to be a significant portion of their market where they're selling through the DoD. I worked with, a couple of years ago, I worked with a high pressure air compressor company that was going digital, right? Had been very analog throughout their history, old company, been around for a long time. They were taking themselves digital, but the DoD was a big section of their marketplace. You need high pressure air compressors to start those engines on US Navy ships, those gas turbine engines, got to have an HP air compressor. So when they digitize that, it's important for that software development, all of that stuff to be protected, because I don't want a Chinese Trojan in there that's going to disable the ability to start my engines when I need it, right? How important is that to your business? I don't know. I think that's going to be a different conversation for every business. Some of them, hey, the DoD is 80, 90, 100% of what I do. That's critical. You guys need to start thinking about this. Right. If it's 20% of your business, then you need to think about, well, how do is that important to me? Do I spend money on it? Do I need to look at this or not? I think that's a call that every company is going to have to make.
So I want to make sure that we're just cutting right to the chase on this point. Is the DoD CISO says if you're not in compliance with at least level 1 of CMMC standards, then you don't get to play ball with any DoD equipment from a cybersecurity standpoint. But what you're saying is the archaic nature of a lot of these standards may be prohibitive for a new company with better technology to provide it to the DoD. So isn't that sort of a paradox, right? Is that what you're saying?
That is the problem that the DoD faces in rolling this standard out.
Wow.
And it's one of the risks that has been talked about. Now, what I would like to see, and what I think you're going to see in the marketplace, most of those small companies now use managed service providers from an IT perspective, right? They're not doing it themselves. They're hiring somebody to do it for them. I think we're going to begin to see managed service providers in the space that are compliant and can do 80 or 90% of that work to get those small companies, small and medium-sized companies, so they can buy it as a service. That's coming. Those offerings I don't really think are in the market yet. There are some people that claim that. I would be very skeptical of that today. I've not seen one yet that passed more than the 30-second sniff test. They just aren't there yet. But I do believe that is one of the things, that ways the market will respond to the requirement, is there will be MSP offerings that help fill that niche. And I think that's going to cover a fair amount of that gap. Not all of it. There will be some entrepreneurial companies who will decide, I really don't want to bother trying to sell to the DoD. That's not going to be in my first business model. I'm going to go sell commercial first. And maybe down the road, if I decide to do that, I will, because complying with their cyber standards is too onerous.
So Vince, we talked about CMMC at least at its lowest levels. What about at the high end? You know, do you start as you go up 2, 3, 4, 5, start to realize some significant advantages from a security standpoint, you know, once you get over that initial hurdle of investment and requirements from the DoD?
I do think at the higher levels of the standard, you start to get into very, very good security practices that, you know, if you're going to be a APT resistant company, following the CMMC standards at the 4 and 5 level will absolutely put you in a good position to do that. I think as we saw with SolarWinds, nothing makes you impenetrable. But CMMC does have it's a good standard, particularly at those higher levels, because the things that it tells you to do are industry best practice.
You hit it right on the head, Vince. There's nothing to be gained from security, but there's a huge amount to be lost.
Right, and it's just we as humans find it hard to tell, right, and hard to quantify that risk and really understand it. And one of the things, so I'm a big guy. I know that small and medium-sized companies can't afford GE Aviation Security or Walmart Security, right? I can't have a 50-person company and a 50-person security organization that's running my security operations center. That dog ain't going to hunt. Clearly. But what I think, back to my college club sport analogy, I think we can raise the level of play all the way along, and that companies should be making themselves as hard a target as they can so that they slow bad guys down, they reduce their risk. There's nothing I hate more than seeing a small technology company shut down because somebody stole their stuff, or somebody stole the last payroll and they can't make up another payroll based on their cash flow, and they just fold, right? And that happens, and I've seen that happen. I absolutely hate that. That's well, honestly, a big part of the reason why I'm in this business is because I hate to see that, and I want to do everything I can do to help protect American companies from being robbed and put out of business by these folks who would just steal and destroy everything.
So Vince, if you're trying to prepare for an assessment, you know, for the DoD, what are some of if you're a small to medium-sized business, what are some of the best practices and steps you should take? You know, I guess, you know, swallowing the pill too, that you may have to put some on-prem infrastructure in, or, you know, something like that. Where do you start?
Yeah. So I think number one is have a plan, right? So your first step is to know that you have a requirement. What does that requirement mean to your company? And then have a plan for how you're going to get from wherever you're at today to where you need to be. The Department of Defense has put out, and a lot of small and medium-sized businesses are starting to see this, has added a new regulation along with CMMC that says, turn in your homework and tell us how you're doing against the standard that existed before CMMC, which is, in brief, NIST 800-171. Tell us how you're doing against implementing all 110 of those controls. So every contractor and subcontractor who has controlled information, which in my view is a great many of them, more than I think the DoD estimates, are supposed to turn their homework in. So step one for most small companies that are really in the DoD space, have I turned my homework in yet? And if you don't know about that and you go, what cyber homework? Please engage somebody who does know about it, who could lead you through the process of the Supplier Performance Risk System, SPRS, for the Department of Defense, and how you get your stuff in there. The next stage is that will baseline kind of where you're at. Then you need a plan that says sometime over the next 5 years, CMMC as a compliance requirement is going to come home. If I'm working on a DoD contract or as a sub on a DoD contract, I'm getting the DoD's money through the supply chain somehow. There's going to be an expectation that I'm at least level 1. What's my plan to get there from here? Because today your risk may be small. They've said there's only going to be 14 contracts this year, and that's only going to impact about 1,500 contractors total out of the 350,000 contractors in the defense industrial base. But someday, in the next 5 years, that risk is going to come home. You need to be ready. And this is not something you do even at level 1. You do not do this in 30 days. You do not say, well, we'll wait until somebody knocks on my door on that, which I've heard from a number of small business owners. And when they do, then I'll take care of that, and I'll, write a policy and put it on the shelf and show the inspector, hey, I've got a policy for this and we're good, right? That's not the way this is going to work. This is going to be an evidence-based assessment. Not only are you going to have that policy, but you're going to have to show them how you're doing against that policy for some period of time in the past. Do not wait until somebody knocks on your door and says you need an assessment if you're serious about selling through to the DOD, because that will be a bad day.
Now it's time for Tech Market Madness with Brandon Lewis.
Cybersecurity firm Dragos recently released its annual Industrial Control Systems Cybersecurity Year in Review report for 2020, which shows that threats targeting ICS and OT infrastructure tripled last year. The 703 identified vulnerabilities were underscored by the company's findings that roughly 90% of its clients had little to no visibility into their ICS environments beyond the IT-OT network boundary. But Dragos isn't the only company looking for vulnerabilities on behalf of the industrial cybersecurity community.
We're just trying to find vulnerabilities and make sure they're being remediated.
That's Sharon Brizinoff, principal vulnerability researcher at Clarity, a cybersecurity company that deals primarily in identifying attack vectors on SCADA and other operational technology networks. Clarity also offers an intrusion detection system, or IDS. The sole job of Sharon's team is to find vulnerabilities in industrial control system hardware, software, and/or firmware. When a vulnerability is identified, it is added to their IDS, and the researchers notify both their clients and the organization responsible for developing the affected components. So basically, when Sharon and his colleagues are on the clock, they are being paid to think like hackers. And last year, they started thinking big.
We wanted to figure out how can we attack from the cyber defense side. How can we attack multiple companies and multiple softwares at once? And that's why we decided to focus on CodeMeter, because we knew it is so commonly used.
Weeboo Systems CodeMeter is a piece of licensing protection software designed to protect IP against piracy, reverse engineering, and outright theft, as well as the ability to flexibly license features and functionality. It's widely deployed on ICS systems like industrial PCs and PLCs from vendors like ABB and Rockwell Automation. It's also used in other industries like automotive and pharmaceuticals. Last year, the Clarity research team took CodeMeter to task and uncovered vulnerabilities that Sharon discovered could enable exploits ranging from the fairly sophisticated to one so commonplace that something like it has probably happened to you or someone you know in the past, a kind of phishing attack.
Through our vulnerabilities that we discovered 6 vulnerabilities. We were able to develop 2 different attack vectors. So the first attack vector is imagine a victim, which can be an engineer or a technician with his laptop, and this technician has some kind of software from a big company, a big vendor, and in the bundle that he installed with this software comes CodeMeter. So this victim, this technician, has CodeMeter installed on his computer, and he's not even aware of that because he installed the big vendor's software. And the first attack vector that we developed is luring this technician to go onto our malicious website. And once he's on our website, we're sending him a specifically crafted JavaScript code that can manipulate some of the licenses on his computer. And so we're basically created an attack scenario that you go on our webpage and the webpage attacks CodeMeter on the machine. This is a very simple technique that we actually seen in different products previously. So the very average hacker could do that. No special skills are needed to do that. And to leverage this, we even developed our own testing tool, so users can go online and test if they're vulnerable. And because this is a very low skill needed, so we even published the POC that people can test themselves.
No wonder the OT guys haven't wanted to connect to the internet. So, don't open those summer promotional emails or visit any unknown websites on your work laptop. Roger that. But what about the more sophisticated attack? What did that look like?
In the second attack vector, the attacker would need to be on the same local area network with the CodeMeter server. So it means that the attacker needs to be on the same network with his victim. And in this case, the attacker will need to send some specifically crafted packets to the CodeMeter server in order to trigger some kind of memory corruption vulnerabilities. And to do that, the attacker will first need to break the encryption key, which is keep on changing all the time because of how Weeboo implemented their encryption scheme. This is a bit more difficult, and it will require some knowledge of reverse engineering and some cryptographical knowledge. So yeah.
But Weeboo Systems uses things like advanced 112-bit ECC encryption and FIPS 140 compliant random number generation in its CodeMeter product. So how are these exploits even possible?
If you're using some commonly used encryption schemes like AES or hashes like SHA-1, it's very hard to exploit these encryption schemes and hashes because they are mathematically very complex. But as you said, usually the issue reside in the implementation. So if you implement these encryption schemes in a wrong way, which means the seed that you are choosing for the encryption process is weak, then it can be easily broken. And this is just what happened in this case, that the seed that was chosen for CodeMeter encryption scheme was very weak, and we could brute force the seed that the key for the encryption derived from. So we reduced the key space from something like 4 billion or something to just 4 million. And we were able to develop a method that we can brute force it at home. So we didn't need to communicate the whole time with the server, with the CodeMeter server. And so we were able to break any key within just a few seconds.
But they had to have some sort of special equipment to do this, though, right? Like a high-end server or tensor processor or something. Well, not exactly.
We didn't use the entire Google's power. We just used a simple, I think, 4 CPU. That's it.
But in any event, these nerds not only have unlimited time to perform this type of analysis, they also probably have unimpeded access to industrial control systems and a full lab at their disposal, even if they didn't need to use a high-performance computer to brute force a poorly implemented encryption algorithm. Can we then put this in the same category as the infamous 2015 GPAC by Chris Velasek and Charlie Miller? An anecdotal project that requires a significant enough investment of time, money, and effort that it would only be worth a hacker's while in rare circumstances, and therefore almost hypothetical? Well, unfortunately, that's not the case.
When someone finds a vulnerability in Microsoft, everybody knows about it. And suddenly, in the last few years, more and more vulnerabilities are starting to be discovered in ICS. And the reason for that is because ICS equipment becomes more approachable for researchers. In every factory, in every company, in every plant, there is PLCs, HMIs, and equipment that you can buy on eBay. I'm not sure if you knew that, but almost every embedded system can be bought on eBay. So it's true that maybe you don't have access to the real thing, to the real equipment, but you can definitely set up a lab with very similar equipment, and you can research that. The vulnerabilities are still there. It's just a bit more hard to get the right equipment to find this.
I decided to check eBay for myself, just to see what sort of ICS goodies were available for the taking. And after typing in PLC, right there they were. a Siemens logic module, more than 10 of which were available for sale, and 248 of which had already been sold, an Allen Bradley Ethernet PLC, 2 Omron controllers left from an original collection of 5. All of them were less than $500, and some were even less than $130. Fortunately, Sharon and his team of white hat hackers are the good guys. As soon as they identified the vulnerabilities, they informed Weeboo of the issues, who immediately remediated the bugs and passed along the fixes to their customers in the form of new versions of the CodeMeter software. But if this happened to Weeboo, a company whose motto is perfection in protection, licensing, and security, the question is really, who else could it happen to? Who else has it happened to? And who just got a PLC delivered to their door and is about to start hacking? The inconvenient answer to all of those questions is anyone.
There are always going to be bugs. It really depends how you handle the bugs when they're reported, and if you're routinely doing some security analysis on the product. So I think if someone reports a vulnerability to you, you must take action immediately, and you must try to solve it and work with the researcher or the hacker that provided this information. And also, you need to perform your own self-inspection. So you need maybe to hire a third-party security firm to test your products, or maybe hire a full-time employee to do just that, to try to find vulnerabilities in your own product. So if you're playing with your product and you're trying to take it to the extreme and find bugs in it, so I'm sure it will improve the state of the security of any product.
These may seem like no-brainers, but they are the security best practices akin to brushing your teeth in today's world of ubiquitously connected ICS and OT systems. After all,
bugs will be bugs.
Thanks for listening to this edition of Embedded Insiders. For daily industry news, videos, and podcasts, visit our website, embeddedcomputing.com.